Bumper cars, roller coaster, horror houses, and various attractions are what makes an amusement park the eye of the candy, not only for the children, but literally to everyone. So, do you know what completes an amusement park? Yes, you guessed it right. A Ferris wheel. Round structure, rotating motion, and fancy lights. Just like a short stop above to rest and enjoy the view. But have you ever wondered why it was made to be in a rounded shape? Not square, not a hexagon, but a circle. Well, this day we can be exploring not just the circle, but everyone in the conic sections as they play roles in our everyday applications. A conic section, or simply conic, is a curve obtained as the intersection of the surface of a cone with a plane. It consists of three types, which are the parabola, the hyperbola, and the ellipse. The circle is a type of ellipse, then is sometimes considered as the fourth type of conic sections. You may not notice, but these four conics can be observed everywhere. Now let us explore more into the real-life application. A circle is a round shape whose points are all the same distance away from a center point. It is the locus of points that moves such that its distance from a fixed point called radius is constant.
When I eat in the morning, I see a round plate. When I buy something outside, I see a round coin. When I get out and see the car drive past me, I see their round tires. And you realize, you see, everywhere we look, there is a circle.
Let's talk about a Ferris wheel. A Ferris wheel is an amusement park device consisting of a large vertically oriented steel, revolvable on its horizontal stationary axle and carrying a number of balanced passengers or open seats around its rim. The seats are suspended so that they remain horizontal as the wheel rotates, and depending on the size of the wheel, passengers may have a grand vista of the surrounding area when they reach the top.
Did you know that the nostalgic ride was named after George Washington Gale Ferris Jr.? He is actually the American engineer who invented it.
There are several parts of a circle. First, there is center or the point in the middle of the circle, wherein its distance to any point in the circle is constant. The distance, meanwhile, is called radius.
The diameter is 2 radii. It is the length of the line through the center that touches 2 points on the edge of the circle. Another part observable in each conic section is the vertex, an extreme point on a conic section. The locus are the set of all points whose coordinates satisfy a given equation or condition.
Next is the focus, a point used to construct a defined conic section at which ray reflected from the curve converge. Its plural form is foci. The minor axis is perpendicular to the major axis at the center, and the covertices are the endpoint of the minor axis.
This shape is important because we use them in our daily lives. Think about the way we travel. It would be rather difficult if we didn't have circles or our wheels to take us from point A to point B. What about you? Would you rather have square for tires?
Well, why not? That could be cool.
Although it'll take you years to visit me at my home.
Just a quick look around you, and you are bound to see circles in so many different applications and interesting way. You see them in our cars, in a bicycle, and even our clocks. So just look around and observe, and you will always see the shape of circle. Thank you.
Looking around, life is literally full of circles. Moving on, the second conic section is the parabola.
If I remember correctly, there was this movie way back 2018 and it was called Aurora. And the story was like tackling about the ghosts of people who died from a shipwreck. It was haunting, really. But hey, did you know it was based from a true story? Well, It was actually the story of the MV Donna Pass by the HMS Titanic, which was recorded in history as the worst and deadliest maritime disaster that happened in Asia. It was a Philippine-registered ferry that collided with an oil-empty vector on the midnight of December 20, 1987, killing over 4,000 people.
Well, lack of proper communication and safety were blamed for this. Imagine being at the middle of the sea on a night of darkness without knowing that it would be the last moments of your life. Now that is scary.
But what if multiple shipwrecks happened in just one night? Like, wow, that would be a total wreckage.
And that is very true. So much could be in danger if that would have happened.
Fortunately, there comes the presence of a lighthouse. It is a structure designed to aid maritime coastal navigation by being a beacon of light that warns the mariners of hazards, determining their position and guiding them to their destination.
Over the centuries, lighthouses have been under different variations and improvements to its light emission. A flat surface caused a scattered light. A spherical one increased the brightness but wasn't able to produce a powerful beam. And lastly, a parabolic one that helped focus light into a powerful beam that could reach long distances.
There were various types of parabolic light reflectors. One was even the most common now, the Fresnel reflector, wherein its lens was cut down into step sections. This preserved the curve of the reflector and even helped the beam of light to be focused in only one direction.
If the reflector was cut down, then why the effort to maintain its parabolic curve?
Well, the lighthouse's reflector shape, a parabola, is described as a locus of a point that moves in a plane so that its distance from a fixed point is equal to its distance from a fixed line. It is often easily recognized for its U-shaped feature that is very distinct from the other types of conic sections.
The focus is the fixed point F of a parabola, directrix is the fixed line D of a parabola, and the vertex is the point on the parabola which is halfway from the focus to the directrix. Did you know that the equidistant point and line from the definition of the parabola making it distinct is the focus and the directrix?
The axis of symmetry is the line passing through the focus and perpendicular to the directrix. It divides the parabola into two equal parts. And lastly, there is the latus rectum, a focal chord that connects any 2 points of parabola passing through the focus and perpendicular to the axis of symmetry.
Perhaps researchers, inventors, and even engineers wouldn't bother to apply changes with the shape of the reflector if it wasn't relevant.
Parabolic reflectors actually challenge their manufacturers because of its hard-to-shape physical feature, although changing its function as a reflector remains due to its geometric properties of a parabolic shape.
Some of the importance its shape contributes to the main purpose of the reflector are first, its angle of incidence to the inner surface of the collector equals to the angle of the reflection, making any incoming ray of light parallel to the axis of the dish reflected to a certain point or focus.
Second, many types of energy can be reflected with a parabolic reflector, and it can be used to collect and concentrate energy that enters the reflector at a certain angle.
And third, energy concentrated to the focus will be radiated back to the dish and be transmitted outward in a beam parallel to the axis of the dish.
Before, the reflector was placed behind the light source, but later on, clever scientists have also discovered that it can be placed in front of the light source. This way, the energy can be more focused in an angle thanks to its curved form. Got curious to conic sections after the first two? Well, let's now go to the third one, the ellipse. An ellipse is the locus of all those points in a plane such that the sum of their distances from two fixed points in the plane is constant.
The fixed points are known as the foci, which are surrounded by the curve. The shape of the ellipse is in an oval shape, and the area of an ellipse is defined by its major axis and minor axis.
The ellipse is one of the conic sections that is produced when a plane cuts the cone at an angle with the base. If the cone is intersected with the plane parallel to the base, then it forms a circle.
Does anybody here loves football?
American football, known in the United States and Canada simply as football, is a competitive team sport. The objective of the game is to score points by advancing the football into the opposing team's end zone.
The ball can be advanced by carrying the ball or by throwing or handing it from one teammate to the other. Football is a game of two teams which has an 11 players using their any parts of their bodies except for their hands and arms.
Only the goalkeeper is permitted to handle the ball and may do so only within the penalty area surrounding the goal. The team that scores more goals wins.
In Canada and the United States, a football, also called a pigskin, is a ball, roughly in the form of a prolate spheroid, used in the context of playing gridiron football, while spherical balls come from the two-dimensional shape of a circle. Footballs are formed from a two-dimensional shape called an ellipse.
An ellipse can be divided by its two axes, its longer major axis and its minor axis. If an ellipse is rotated about its major axis, you obtain a rugby ball.
Unlike a spherical ball, the prolate spheroid shape actually helps the football to spiral through something called the gyroscopic effect, which helps maintain its control and trajectory by its continual speed.
The unique shape of the football, for example, contributes to the dynamic nature of the ball itself, which can be thrown long distances in a tight spiral or bounce unpredictably in a field of play.
A football, however, owes its two-dimensional origin to the ellipse rather than the circle, giving the pigskin its prolate spheroid shape, which has a polar axis that is greater than its equatorial diameter.
Thanks to its elongated nature, a football will spiral when drawn properly. The spin creates a gyroscopic effect, stabilizing the flight of the ball through the air. This shape makes the football more difficult to throw than a spherical ball.
But as a prolate spheroid, the football experiences less drag as it cuts to the air, which explains why you can toss a football farther than a spherical ball such as basketball or soccer ball that is roughly the same size and weight.
We have seen circle, ellipse, and the parabola, and all of them have real-life applications. Well, what was the last one again?
Hyperbola.
A hyperbola is a set of all points in a plane, such that the difference in the distance from two fixed points or foci is constant. Real-world situation can be modeled using the standard equation of hyperbolas. For instance, given the dimension of a cooling tower, we can find a hyperbolic equation that models its side. Cooling towers have become the design standard for all natural draft cooling towers because of the structural strength and minimum usage of material. The hyperboloid's shape also aids in accelerating the upward convecting airflow, improving cooling efficiency.
Now, there are several parts of the hyperbola that can be laid out on the hyperbolic cooling tower. First, the center or the midpoint of the transverse axis, the vertices or the endpoints of the transverse axis, co-vertices or the endpoints of the conjugate axis, the foci, the two fixed points, transverse axis or the line segment joining the vertices and containing the foci and center, conjugate axis, the line segment joining the co-vertices and perpendicular to the transverse axis, the asymptotes or two lines intersecting at the center, and lastly, the latus rectum or the line segment through any of the foci perpendicular to the transverse axis and whose endpoints lie on the hyperbola. Now, there are several parts of the hyperbola that can be laid out on the hyperbolic cooling tower. First, the center.
It's really amazing like how the concepts of these curved sections are being applied in real life situations. But the only thing I know is that I do like my coin circle.